morning, sir. Good morning, my friends. Myself, Pinchu Sarkar, and my teammates are Tanmay Niyoti and Shantanu Samanto. Today, we will discuss about hydrogen fuel cell. So, here's the contents of the topic, like introduction, what is green hydrogen, history of fuel cell, how does the hydrogen fuel cell works, application of hydrogen fuel cells, etc. Introduction. Hydrogen fuel cell is a zero carbon fuel which burned with oxygen and provided it is created in a process that does not involve carbon. It can be used in fuel cells. Besides this, it is also used for fuel. It is also used as fuel for spacecraft propulsions. Generally, we know that hydrogen is the first group. Hydrogen is found in the first group and the first pure in the periodic table. That is, it is the lightest element. So hydrogen is rarely found in its pure form in the atmosphere. So here is the reaction. Whereas hydrogen in flame of pure hydrogen burning in air, the hydrogen reacts with oxygen to form water with the release of energy. History of the hydrogen fuel cell. In 1766, hydrogen was identified as the first distinct element by British scientist Sir Henry Cavendish, and after that, in 1838, German scientist Sir Christian Friedrich discovered fuel cells. After that, in 1839, Sir William Robert Brock clearly demonstrated it, and he is also known as the father of fuel cells. So, what is hydrogen fuel? Hydrogen is a clean fuel that, when consumed in a fuel cell, it produces only water. Hydrogen can be produced from a variety of domestic resources such as natural gas, nuclear power, biomass, and renewable power like solar and wind, etc. These qualities make it an attractive fuel option for transportation and general electricity applications. Besides this, it is used in cars, in house, and in many more applications. Types of hydrogen fuels. There are types of hydrogen fuels. Hydrogen is categorized as mainly into four major categories. First one is gray hydrogen, which is produced by breaking down methane or coal by the process called gasification. And the next one is blue hydrogen. And the next one is blue hydrogen, which is exact like gray hydrogen, but in this case 95% of carbon is actually captured, stored and reused. And then we have third types of hydrogen, that is compressed hydrogen. It is produced by the process of pyrolysis. And the last one is green hydrogen, which is produced not using methane or coal, but it gets from renewable energy, and by the process is called electrolysis. It is the cleanest form of hydrogen within no carbon content, it is the cleanest form of hydrogen within no carbon byproduct at all. So actually carbon is not hydrogen is not the source of energy. It is the energy carrier. So next part will be.
Good morning everyone, myself Santanu Samanto. Now we will the mechanism of hydrogen fuel cell. Hydrogen is the simplest and smallest element in periodic table. It looks like a battery, but it cannot run down or it don't need rechargeable several times. It can produce electricity continuously. It can happen in high efficiency in combustion engine. It composed two parts. One side anode and other side is cathode. They are separate with a electrode member. The hydrogen will pass through the anode and other side the oxygen pass through the cathode. Anode split the hydrogen molecule with proton and electron. The proton can pass through the electron member, but the electron cannot pass through the electron member. But anode needs equal energy. So in that time you need an external circuit to pass through the electron and to force the electron to pass through the cathode side. The flow of electrons make the electronics in electric energy, and the end of the process the proton and electron and oxygen molecule compose to water molecule. Application of hydrogen energy, transportation, steel industry and chemical industry. Application of hydrogen energy in transportation. Battery. First you can see there is an auxiliary battery. It just starts the vehicle when the traction battery is not engaged. Next, battery pack. Battery pack is high voltage battery stores energy generated from regenerative braking and provides several power and electric traction motor. There is a DC converter. It's converted high voltage DC power from traction battery to the low voltage DC power for auxiliary battery. Then electric traction motor. Electric traction motor is using the power of fuel of the traction battery and it drives the vehicle wheel. And some vehicles use motor generators that perform both. They can drive and they can do regeneration function. Fuel cell stack. We said before, the fuel cell stack will see a electron membrane and anode and cathode. They are using hydrogen and oxygen to produce electricity. Fuel filler. Fuel filler is basically a nozzle from the fuel of dispenser attached to the receptacle of the vehicle to the fill the tank. Fuel tank. It stores hydrogen gas for the vehicle until it is filled by the fuel cell. Application of hydrogen steel energy. The production of iron and steel with current technologies requires large amounts of coal, and producing 1 ton of steel releases about 1.85 tons of CO2 on average. It can happen in two steps. First step, iron ore transferred to iron with passing through the blast furnace. Second part is iron transferred to steel with passing through the basic compression of converter. Next, both steps are very energy intensive and are responsible for CO2 emission in quite different ways. In the chemical reaction, CO2 is thrust out by product of iron production. You can see the iron ore, CO2, then coal, iron. Application of green hydrogen energy in chemical energy. Hydrogen is used in the manufacture of two of the most important chemical compounds are ammonia is almost 3% and methanol is 7%, and refining process is actually refine the oil with almost 20%, and others are petrol and removing sulfur compounds from petroleum which otherwise poison to catalytic converter to the cars. It's almost 20%. And other application of green hydrogen, oil refining, glass production, propellant, fuel, and semiconductors. Next one.
About the advantages of green hydrogen over other energy. Now, first of all, we come around that the hydrogen is not a source in itself. It is a carrier of energy. But now we can ask that why don't we use the lithium-ion battery instead of hydrogen? Now, in transportation network, in three factors, we will try to understand the first factor is range and volume of range. Now, in a standard electric vehicle, for a 400 to 500 kilometer range, in an electric vehicle, the lithium-ion battery would take up a space about 400 to 600 liters. For the same range in the hydrogen fuel vehicle, it will take about 50% less space. And looking up to further for 5 years of this development, I can assure that by 100 liters of volume occupancy of hydrogen fuel cell and storage itself, it can give us about 480 to 500 kilometers of range, which is 4 times more than electric vehicle. Now, not just the volume occupancy, the hydrogen is more energy dense. All about 10% of 10 times more than electric lithium-ion battery. So, in case of increasing the range of electric vehicle, hydrogen fuel vehicle, we just need to add some more hydrogen cells. In terms of electric vehicle, if you want to add more range, you have to make the battery bigger. That's why if you increase the weight of the car, you can when the weight of the car is increased, you need more power. Then it will need more battery. It will start a vicious cycle. In this cycle, in a certain times of time, it will be an unconventional and not necessary actually. So next factor is charging time. So in a standard Tesla Model S, half an hour charging becomes for 400 kilometers. And if you wanted to do that with regular charger, it will take 4 hours of charge. But in case, which is enormous actually. In case of hydrogen fuel cell car, a unit that which has a payload of 34 tons for 400 kilometer range, you can recharge it in just all about 88 minutes. Now, it doesn't make any sense for your passenger vehicle, but it can for commercial vehicle it is a game changer. So in case you can see that in the graph, so for a standard electric vehicle is 10 tons and it has a 160 kilometers. For commercial vehicle of fleet of taxis, if a taxi owner is tries to drive a 160 kilometers, then charge it for 4 hours, it is not very economical for them. So as the transportation vehicle too. But in terms of hydrogen fuel vehicle, it can recharge it in 8 minutes, and obviously the range is much higher. Like the bus of 80 tons, 80 ton bus of hydrogen fuel cell, you can range up to 400 to 5 kilometers. And the transporter vehicle like a truck or a train, which has a 180 ton of weight payload and a train of 1,000 tons, you can increase the range about 1,000 kilometers. That is the most common. Another third factor is volume energy density. Now there is a mistake actually. The 3 times more energy than battery. It only happens. It will be 3 times more energy dense than petrol. Actually, you can see in graph the energy of petrol is in between 20 to 40 megajoule hour per kg, whereas the hydrogen fuel stand with 120 megajoule hour per kg. Now, the second and most common advantage of the hydrogen fuel vehicle is the renewable energy. So it creates less pollution. So today we know that climate change is real, and the average temperature of the planet is increasing. So scientists have predicted that to reduce the temperature by 1.5 degrees Celsius, the global carbon emission need to drop to 0 by 2050. So as a hydrogen fuel is a renewable energy. So it doesn't have any byproduct of carbon. It only creates byproduct of hydrogen, pure drinkable water. So in case there is a key major industry in case of India or abroad, steel industry, transportation industry, and chemical industry, which so much dependent on fossil fuel that the steel industry alone creates 35 to 33% of pollution. So transportation creates 20%, and chemical industry has a footprint, carbon footprint of all about 12%. And you can see that in the graph that carbon emission in India next 3 decades will increase from 2050 by 2050 to 42 metric tons to 897 metric tons. This is huge. So now, what India is doing about green hydrogen? Green hydrogen for Indian industry. Yes. Now, this is a complex thing actually. So, recently you introduced a new tax called carbon border tax. Now, what is carbon border tax? In simple word, you will impose another excess level of tax if your carbon footprint is over the certain level. So what does that mean? Then the Indian steel industry comes, which is second largest in the world, and it is exported about 13.5 metric tons single 2021 financial year to just Europe. So if you start to impose the carbon border tax, it will increase the price of Indian product at the EU market. So the margin will decrease, and India have to have a trade deficit of billions of dollars. And Indian steel industry is a superpower for India, and also biggest pollution sector of India and world as well. So in case of to secure the trade of EU, you have to change the dependence of fossil fuel, fossil fuel to renewable energy like hydrogen. Now, we all know the air quality index of India. Now, 6 out of 10 cities of India is currently at the top most polluting city in the world. So you can see the half of Delhi pollution caused by vehicles. It's not just Delhi actually. Whole world actually, whole India is also dependent. Whole India's pollution actually half of is caused by transportation. So and transportation, over 90% of transportation is still dependent on fossil fuel. So not just to create less pollution, we have to choose from fossil fuel to renewable energy, not just hydrogen or any kind of renewable energy. Now, geopolitics around fossil fuel. Now, you can see that India just committed about that by 2050 it will reduce 50% of this carbon footprint. Then why India is aggressive so about its carbon footprint? Because in terms of the point, you can understand that India is very much dependent on for fuel in Middle East. That's why it is in terms of geopolitical tension, it can give India a big oil shock. Secondly, now every leader understands that the climate change is here. So they started a pact called 193 countries come together and complete a pact called Paris Agreement. And the number 3 sector is India's 3 biggest sector I just talked about. Steel, chemical and transportation is still dependent upon fossil fuel. And you have to change it to reduce the carbon footprint. So recently Mukesh Ambani actually $75 billion plans to make India hydrogen hub. So Adani also invested $70 billion in renewable energy for solar, and Tata also started making buses for renewable that will be driven by renewable energy. Now, most like many other cases, hydrogen also has some disadvantages of drawbacks, like hydrogen extraction. Despite being the hydrogen sits on the top of the periodic table, and it is the most abundant element on the earth. But it is also a reactive element, so hydrogen does not exist on its own, so needs to be extracted from water via electrolysis or separation from the carbon fossil fuel. So it is a very energy extensive process and a cost of raw material. So in hydrogen fuel cell, we use a catalyst made of platinum and lithium, which is rare metal and very costly metal. and also storage of hydrogen and extraction of hydrogen is also costlier. Next is hydrogen storage. So we know that hydrogen storage is not an easy thing. You have to store it in a liquid stage or a gaseous stage. In liquid stage, if you try to liquid stage, you have to store it. Then the temperature needs to be much more lower. And for this, the storage of hydrogen is much more complex, and it is a costlier also. So makes highly flammable. Hydrogen is a flammable gas. So we bring understandable safety concerns. As it is a flammable gas, so it will have some concerns to infrastructure. So right now India does not have a really good infrastructure for storing or selling hydrogen as a fuel. It will need some improvement in 5 years. For next slide, conclusion, I will invite.
So, after this discussion on this topic, it is this conclusion that hydrogen fuel cells are a promising alternative to current automobile fuels. The advantages of hydrogen fuel cells as one of the best renewable energy sources are evident. However, there are still a number of challenges to overcome to realize the full potential of the hydrogen as a key enabler for the future decarbonized energy system. One is hydrogen could become the best solution for the future of our energy requirements, but this will require investment to achieve. However, as fossil fuel run out, hydrogen could be a key solution for our global energy needs.
Now, the acknowledgement for attending here, we would like to thank you, sir. For reference, there is a just to level Google internet. That one actually I searched. There is a channel called Things with That. So much described very well actually for India and this hydrogen fuel. You have to check it out. The link is not given actually, but you will search it by Things. And there is a paper published by Cambridge University about hydrogen fuel and its technicalities. This is the most reference I actually used for this. You can search and